Here we are again. We're going to finish up Chapter 3 by looking at both Lessons 9 and 10 together. They're very similar. They definitely kind of go together. So in Lesson 3.9, we're talking about fractions and decimals and how they relate to each other. So remember, we've said all along that fractions really are a division problem. That fraction bar is also a division sign. So if you have 5/8, it's 5 divided by 8. And when you divide that, you get a terminating decimal, meaning that it's these three numbers and then it's finished. There's nothing left to divide. So this is called a terminating decimal. When we have a number that repeats in the division process, like 3 divided by 11 will come out to be 0.27, 27, 27, 27, and 27 forever. It'll never end. This is called a repeating decimal. And we write it with a bar on the top of what repeats. If it was one number that repeats, like 1/3 would be 0.33333 repeating. So we would have a bar over just a 3 because the 3 is what repeats. In this instance, it's two numbers that repeat. 27, 27, 27. So we put the two numbers with one bar over the 2. Now, on our calculators in the classroom and possibly yours at home, depending on the kind of calculator you have, ours at school are smart. Meaning, it doesn't just chop it when it gets to the end. It actually will round it. So if you see something that looks repeating, like 27, 27, 27, and all of a sudden there's a 3, it's not just going to, like, all of a sudden be a 3. It's a 3 because of the fact that it knew that this was a 2, but the next one that didn't fit was a 7, and so it rounded it up. So when you see something like that on our calculators especially, but possibly yours at home as well, you need to realize that that didn't just all of a sudden terminate and there's a 3 there. This really is a repeating decimal. And so you would still write it as a 0.27 repeating. Now, when we're talking about changing a decimal into a fraction, or possibly a mixed number, this is how we do it. In the decimal, the whole number becomes the whole number. Okay, so the number in front of the decimal place will be the whole number. All right, let's say, for example, we had 3.5. So the number in front of the decimal will become the whole number of the fraction. Okay? The decimal part will be over whatever place value it is. This 5 is in the tenths column, so it's 5/10. Now this can be reduced or simplified, so we always simplify our fractions. I can divide both 5 and 10 by 5, so that would be an equivalent of 1/2. Okay? One little trick here is if you just say the decimal the correct way, you can definitely write it. So here's an example. 3.25 is not the right way to say it. It's 3 and 25/100ths. Okay, so 3 and 25/100ths. And we can definitely reduce this. All right, let's look at another example. If we had 1.325, okay, think about how you would read it. 1 and 325 thousandths. Now we would need to simplify that, And here's a little trick. When you're doing these decimals, you're always going to have a power of 10 down here. Always try to divide by 25. If the numerator will divide by 25, guaranteed the denominator will too, because 25 goes into 100. And you can use a calculator. It's okay. So 325 divided by 25 is 13. And 1,000 divided by 25 is 40. So your decimal, 1 and 325 thousandths, simplifies to a fraction of 1 and 13/40. Here's a more simple fraction, decimal, 6/10. Again, we normally get caught up in saying 0.6, but think about how you would say it for real, the real way to say it, 6/10, and write it that way. Then look for some number that you could divide both numerator and denominator by to simplify it, and we would get 3/5. So 6/10 is equivalent to 3/5. Now let's go on to lesson 10. Lesson 10 has to do with rational numbers and comparing them. So the first thing you need to understand is, what is a rational number? A rational number is any number that can be written as the quotient of two numbers. That's the definition. But what does that mean? It means that it's all these things. All whole numbers are also considered rational numbers. All integers, which remember are whole numbers and their opposites, those are all rational numbers. Fractions are all rational numbers, including whether or not they're negative. Terminating decimals, whether they're negative or positive, those are rational numbers. And so are repeating decimals, even if they're negative. Okay, all of these numbers are rational numbers. So that's really just a definition for you. Now, how do we compare rational numbers? Well, it's easy when they're positive. If you had a 0.2 or a 2/10 and you had a 5/10, you would know which one is bigger and which one is smaller. Comparing, remember, means we're going to use greater than, less than, or equal to. The only difference with comparing a rational number is that you have to remember that the opposite is true. So here is an example. If you had a positive 3/10 and a positive 1 8/10, you would know that 1 8/10 is larger. But since they are both negative, the opposite is true. Negative 3/10 is greater than negative 1 8/10. So honestly, the best way to do these when you have two negative rational numbers and you're comparing them, the best thing to do is to ignore that they're negative, figure out which one's bigger, and then flip the direction of your sign, because the opposite will be true for the negative numbers, the negative rational numbers. All right, let's give that a try.